Now, number 3, the curl of vector field. The definitions of curl for any vector fields: curl A equal. It is the limit when the volume approach to point for the enclosed surface integral for the cross product with the ds over delta V. Now I will write A in rectangular coordinates. It is the curl A equal the matrix. I will write A sub x hat. It's another symbol for the unit vector. And A y hat, A z hat for the number 1 partial x, partial y, partial z, and for the vector fields it's A sub x, A sub y, and A sub z. This is cross product. It's equal the partial AZ over partial y minus the partial z for the AY. This is AX hat plus the partial AX over partial Z minus the partial AZ over partial X. This is AY hat plus the partial AY over partial X minus the partial AX over partial Y. It is A sub Z hat. B, I will write the curl in spherical coordinates. The curl, in cylindrical coordinates in the first. Curl A, cylindrical coordinates. It's equal to the matrix of A sub R hat, A sub phi hat, A sub Z hat. The partial R, partial phi, and partial Z, A sub R, and we must not forget 1 over R from the gradients of cylindrical coordinates operator, and R of A phi, and here also R, and A sub Z. Like this matrix, we can get the kernel A for R, AR hat, plus the kernel of A for phi, A phi hat, plus the kernel of A for Z, AZ hat. The last one is the spherical coordinates for the kernel. I just write C in spherical coordinates, the kernel of A in spherical coordinates 1 over R sine theta, and I will write it here. 1 over R square sine theta for the matrix AR hat, A theta hat, but I will write R, and R sine theta for the A phi hat, partial R, partial theta, and partial phi. This is A sub R, and this is R A sub theta, and also R sine theta A phi. This is equal to the kernel of A for R, AR hat, plus the kernel of A for theta, A theta hat, plus the kernel of A for the phi, A phi hat.